Okay, the recording has started. Okay, so anyone have any doubt up to this point?
No, sir.
Okay, so let's start. Good evening, everyone. My name is Chandan Kumar Gupta. I am a Prime Minister Research Fellow in Department of Mathematics, IIT Patna. I am your NPTEL PMRF Teaching Assistant for the course Probability and Statistics. This course is offered by Professor Somesh Kumar. He is a faculty in IIT Kharagpur. This is the last week of our course. Okay, so after that, I think you people have your examination on 26th of April or 24th of April. Maybe I think 26th will be the date. Okay, and if you people have any kind of doubt, okay, you may ask me via my LinkedIn, okay, or this YouTube channel. All the recordings has already been uploaded on this YouTube channel, and you people have already got the links from the NPTEL side as well. Okay. Okay, then let's start. See, this course is designed for introduction to probability and introduction to statistical inference. Okay. So from first 1 to 8 week, this is week 10. Okay. From 1 to 8 weeks, we will mainly focus on the probability theory part. Okay. And from 9 to 12 weeks, we will, like we have discussed about the statistical inference part. Okay, so this is the 12th week. In the 11th week, we discussed about the testing of hypothesis. Okay, so we will continue from that topic today. Okay, before that, in 9th and 10th week, we will discuss about parameter, then statistic, then estimator, then estimates, and then about the point estimation, the techniques or the methods to find out the estimates of the parameters, like the maximum likelihood estimation, the method of moment estimator, etc. Okay. Then we have discussed about the confidence interval as well. Okay. Confidence interval for mean, for variance, okay, for the normal population. Then in 11th week, testing of hypothesis, types of errors associated with those hypotheses. Okay. And then in today class, we will discuss about test for some like parameters. Yes, yes, this is the last live session actually. Ayush, this is the last live session. Okay. It may possible that I may not see the chats because I'm like being here. So you may directly interrupt me and ask me here as well. You may write whenever I get the time. I will see the chats and respond accordingly. Okay. This is the last.
It is like
Yes. Sorry. Okay then. So let's start. Today we will discuss about test. Okay, we will conduct some testing. So the first, let me start. Test for means. Okay, like okay, these have already been discussed in the lecture. Actually, I'm just writing the formula and the concept that we are going to use to solve the numericals. So test for mean of normal distribution. So again, these are the kind, like let x1, x2 up to xn be a random sample from the normal population, be a random sample from normal population with mean mu and variance sigma square. Okay, this is usually the common line in all the testing. Then we need to test the uh, mu. Okay, we need to test the mean mu. So how to test? See, we have two or three or four scenario based on the problem. Here, we need to test for the mean of the normal distribution, and the another parameter is sigma square or the variance. So possibility is either sigma square is known or sigma square is unknown. Okay, so we will perform like under known sigma square, and another one is sigma square is unknown. Okay, these are the two possibilities, and under these two scenarios, we will conduct the hypothesis testing. Okay, how? There are four steps. Okay, there are only four steps. First, you need to like construct the hypothesis. You need to frame the hypothesis. Then, on the basis of the problem, like and just like here, I need to perform the test for mean. So the scenario is like either sigma square is known or sigma square is unknown. Second step is you need to like find the statistic which is used in that scenario. Okay, known in known case there is some statistics is defined. When sigma square is unknown, then some other statistic is defined. Okay, so you need to find out which statistics is used for the performance of for the performing the test. Okay, the next is you need to find the critical value. Okay, you need in second step you need to calculate the critical calculated value. Okay, the statistic value. Then the next step is to find the critical value from the table. Third step is the involving the critical value. And at last you need to make inference, you need to make conclusion based on the critical value and the calculated value. These are the only four steps that involved in any kind of testing. Okay, always remember, frame the hypothesis, then statistic, you need to calculate the statistics. The third one is you need to find the critical value at the given information, like the at some level of significance, some degree of freedom. Okay, and at last you need to make conclusion based on the critical value and the calculated value. Okay, so we will solve numericals based on those. So let me start. So first is like sigma square is unknown, known. I'm going to say in that scenario, we need to test the mean. So the first thing is what is my hypothesis? Okay, so the hypothesis is obviously I need to find out H naught such that mu equal to mu naught against H1 such that mu is not equal to mu naught. Okay, is greater than mu naught and is less than mu naught. There are three possible cases actually. Okay, so let me first write the, this is the general case. Okay, this is the general case. The first one is the kind of general case. Okay, H naught. So let me first write the hypo statistic for sigma square norm. Then I will write three different sequence, and then on the basis of those sequence we will conclude. Okay. So the first thing is like when sigma square is known, the Z, the test statistic is like Z, which is defined by the symbol Z usually. That is x bar minus mu upon sigma naught by root n. Since it is known, so let's say its value is sigma naught, okay, or sigma naught square. So this is the test statistics because I need to find the mu, that is mean. So the mean can be calculated by the help of the sample. So x bar minus mu upon sigma by root n. Okay. So this is our test statistics. And the second, when sigma square is unknown, in that case, our this does not follow the Z, that is the standard normal variant. This follow T distribution. Okay. Then the test statistic will be like x bar minus mu upon, as we have already discussed many times, that if sigma square is unknown, then we use the estimate of sigma square. And the one unbiased estimate of sigma square is sample variance, that is capital S square. Okay, so that is capital S here, and it's divided by root n, where capital S is what? 1 upon n minus 1 summation xi minus x bar whole square. Always remember, this capital S is capital S square. I mean to say, this capital S square, that is the sample variance, is defined as 1 upon n minus 1. Okay, and this is unbiased estimate for the population variance. If I am writing 1 by n summation xi minus x bar, then it is actually biased estimator. Okay, that we have discussed in ninth week. Okay, like unbiasedness, consistency, efficiency, sufficiency kind of thing. So here, this one is biased and this one is unbiased. Okay, so T, this is T distribution, and this follow obviously the T distribution with n or n minus 1 degree of freedom, because one parameter is missing, that is unknown. So T minus 1 degree of freedom. Okay, at from given a specific level of significance, say alpha. So we need to perform the testing for mean when sigma square is known. In that case, the test statistic will be x bar minus mu upon sigma by root n. When sigma square is unknown, the test statistic will be like, instead of using sigma square, we use S. Okay, because it is the unbiased estimate of sigma square. This is the concept. Now the fourth step is involved like this. Let me write. The first one is, suppose our hypothesis will be like this: H naught such that mu either less than or equal to, usually it will be equal to in in null hypothesis, the simple hypothesis, we need to write the simple hypothesis as much as possible. Okay, so mu is equal to mu naught, or mu is less than or equal to mu naught kind of thing. Okay, which is also like equal to. So against h1 such that mu, since less than or equal to is already taken, so obviously it's greater than. Okay, so what you can see here, it's actually called one-tailed test. We have already discussed the one-tailed and two-tailed. So it is actually one-tailed test, because here the mu is always greater than mu naught is the alternative hypothesis. Okay, so there is only one directional changes possible. So it's a one-tailed testing. Okay, so under this case, what we can interrupt. So suppose you have calculated this value, the z value. Okay, then the z calculated is here. Now we need to find the critical value from there. So we reject the null hypothesis h naught if sigma square is known. If sigma square is known, that means I need to calculate z. In that case, the z value must be greater than z alpha. Okay, since one tail test is there, so z alpha we write z alpha instead of z alpha by 2. Okay, so z is greater than z alpha. In that case, that means that this one is the calculated value. The calculated value, and this looks like 2, but it is actually alpha. Okay, so z is greater than z alpha. That means the calculated value of the z statistic is greater as compared to that of the tabulated value. So in that scenario, we reject the null hypothesis. Okay, so we calculate the first step, we frame the hypothesis, then we find out the test statistic, then we take the value from the table for the given level of significance, and at last we conclude that here we reject h naught when z is greater than alpha. Obviously, when z is less than, then in that case we will accept the null hypothesis. We will fail to reject the null hypothesis. That means, and the second scenario will be like sigma square is unknown. In that case, we will not go to the Z table. We'll go to the T table. So in that case, our statistic is t, that is x bar minus mu upon s by root n. So this value can also follow the t distribution. Since sigma square is unknown, so there is a lack of 1 degree of freedom, and the total sample is n. So the n minus 1 degree of freedom is written here. And obviously the level of significance is alpha. So this value. If the calculated t statistic, this is statistics, if the calculated t statistics is greater than the t value at n minus 1 degree of freedom at alpha level of significance, then in that scenario, we reject the null hypothesis. Okay. And the same structure we need to follow for all the cases. That's why I've given more time on this particular like problem, so that next time I'm just writing and let you know that these are the cases, these are the cases. Here it's simple. When sigma square is known, then we need to frame the statistic. If unknown, then the other statistic is used. Then from the table, find out the values, and then whether either it's reject the null hypothesis or fail to reject the null hypothesis on the basis of the comparison between the tabulated value and the calculated value. Okay, so this is the case. Okay. Again, the same scenario happens once. Now I'm going to write, maybe go to increase my speed now. Actually, second scenario is what? The hypothesis will be like this. If H naught will be mu, since here it's less than or equal to, then it's greater than or equal to mu naught. Okay. In that or equal to is also there. Okay. Or against H1, it's greater than is already taken, so it's less than mu naught. Okay. Again, it's one tail. Okay. In that scenario, what will happen? So again, in that scenario, we reject the null hypothesis H naught if for known case, we need to calculate Z value, and Z tabulated is like this. Here, it is taken as negative. So this is the scenario. Okay. Z is greater than Z alpha in case of this kind of hypothesis, and Z is less than minus times of Z alpha because the Z value take the values from minus infinity to plus infinity. Okay. So this is the case. Okay. So yes, this happens. Now the next is if sigma square is unknown, in that case, we need to calculate the t. And yes, the similar thing happens here. Okay. The third scenario will be like, what if at mu equal to mu naught against h1 such that mu is not equal to mu naught. So this is the example of two-tailed test. Okay, just always try to like see the difference, what minute difference there in the question, because now it's a two-tailed problem. And if it's two-tailed, then what? Reject H naught. Okay. When or if in case of two-tailed, use modulus value greater than or equal to Z alpha by 2. Here I'm not writing like alpha because it's a two-tailed. Na? It's kind of two-tailed. Na? So here like it's 1 minus alpha. So it's alpha 1, it's alpha 2. And for the simplicity purpose, it will taken as alpha by 2 and it is taken as alpha by 2 in other distribution. But in case of normal distribution, its alpha 1 and alpha 2 are equal because normal distribution are symmetrical in nature. So that means alpha 1 equal to alpha 2. And the probability is this maximum major probability is 1 minus alpha. So obviously alpha 1 equal to alpha 2 implies alpha by 2 on both the sides. So that's why we have written Z, the calculated value of Z is greater than or equal to the tabulated value at alpha by 2 level of significance. In that scenario, for tail case, that scenario, we reject the null hypothesis. And the same thing happen for the T when sigma square is unknown, greater than or equal to En minus 1 and alpha by 2. Probably you will get one numerical based on these topic. Okay. I'm not sure 100%, but yes, since it is one of the important topic, how you perform the testing under different cases. So you need to know so that you can able to see the correct value from the table as well. Otherwise, your whole everything is right, but the table value is you may see the wrong tabular value, and you will conclude incorrectly. Maybe it's failed to reject the null hypothesis, but from the table you concluded that you reject the null hypothesis. So make sure. Okay. So this is the case, and the same case has been like occurred for all the cases. I'm going to write now all the cases in as much brief as I can. Okay. So now the second is what? We have performed the testing for mean. The second is testing for variance. Na? So it's test for variance. Anyone have any doubt up to this point that how it works, how the algorithm works, then you please can ask here. Okay. So now the thing is test for variance.
Excuse me,
Yes,
sir.
yes.
Sir, if if sigma is unknown, if n is more than greater than 30 is follows the t distribution, sir.
Yes. See, in case first, what we need to do, first we need to frame the hypothesis. Okay. So there are three possible hypotheses, and that is either mu is less than mu naught, or mu is greater than mu naught, or mu is equal to mu naught. Or we can say on the basis of the alternative hypothesis, either greater than or less than or not equal to. So that is basically either one-tailed or two-tailed. Okay. The next step is on the basis of the hypothesis, you need to perform the testing. Second step is when sigma square is known, then the test statistic is Z. But when sigma square is unknown, the test statistic is T. This is which is already written here. Okay. Suppose this is
No,
one
sir.
and this is
My
two.
question is,
Yes.
my question is,
Yes.
if sigma square is unknown, okay, if n
Yes.
is more than 30, whether that test statistics follows the t distribution or z.
Okay. That's a good question actually. Sorry. See, you may like see the T table. Okay. You will find that after 30 degree of freedom, there is a one common formula for the tabulated value of T distribution for T values actually. Okay. And that is approximately equal to the Z table. So we directly say for large value of n, that is for more than 30 value of n, the t is converging to the z. So we can use the z directly. Okay, this is the case. Just see the t table and z table. You will find that for value greater than 30, the t table and the z table are same actually. Okay, there is a one common formula. I'm not exactly remembering the formula 1.36 upon time something. This kind of formula is there actually. Okay. Is it answer your question?
Okay, sir. Okay.
Okay. For larger
Thank
value
you.
of n, actually t distribution converges to z. Okay. So you may find the t table is actually the z table for larger value of n or for larger degree of freedom. Okay. So overall, more or less both gives the same result. Okay. Now the test for variance. The test for variance is like again uh, for variance we need to mu is either known or unknown. So if mu is known, in that case we need to find the variance. Okay. So in that case w, suppose w is the statistic that we will define here. So it's summation xi minus this mu is known. I have written here mu xi minus mu whole square and divided by sigma square. Okay. This is the test statistic for mu. For yes, when mu is unknown. Let me write here mu naught for known case, and for unknown case, mu is unknown. Okay. Then in that scenario, the test statistic will be like, let me say W star. So it is actually n minus 1 s square upon sigma square. Okay, this is the test statistic. Now, again, we have three conditions here, how the hypothesis is defined. So the first one is like suppose H naught such that sigma square is less than equal to sigma naught square or equal to sigma naught square against the alternative hypothesis sigma square is greater than sigma naught square. In that case, what will happen? Let me write here. Reject the null hypothesis H naught if the statistic is W. Okay, this W is either greater than, so we reject the null hypothesis. Okay, when W is the calculated test statistic is greater than chi square with n degree of freedom and alpha level of significance. Okay, now if mu is unknown, in that case we need to calculate the W star statistic. Again, it follows the same distribution, but since mu is unknown, so we lack 1 degree of freedom, so it's n minus 1 alpha. Is it okay? This is the case because n minus 1 s square, it follows the chi square. Na? We people have already read these things. Okay, so it follows the chi square distribution. So this is the case. The second case will be like h naught such that mu square is greater than or equal to mu naught square or equal to mu naught square against h1 such that sigma square is less than sigma naught square. Now the same thing again going to happen. What? Reject the null hypothesis H naught when W, our W statistic, here it's greater than, so here it's less than or equal. You may write equal to because we are discussing about the normal distribution. So in continuous kind of distribution, the probability at a fixed point is 0. So you may either write the equal to, less than or equal to, or less than, both have the same meaning in continuous case. Okay. But in discrete case, it may be different. It is different actually, not maybe, it is different. So we'll reject the null hypothesis H naught when W is less than or equal to chi square with n degree of freedom. And now the sign has changed. So it's instead of alpha, it's 1 minus alpha because the chi square distribution is not the symmetric distribution. The normal distribution is symmetric distribution. The T distribution is symmetric distribution, but the chi-square distribution is not symmetric distribution. Okay, so it's actually positively skewed. So that's why we will either use alpha or 1 minus alpha depending on the problem. So chi-square n at 1 minus alpha level of significance. And in case of omega, mu is not known. In that case, it's like this: chi-square. The same, it's instead of n, we write n minus 1 because sigma is known, sorry, because mu is unknown. So there is a lack of 1 degree of freedom. So it's n minus 1 and it's 1 minus alpha. Okay. So this is the case. And the third case is like h naught such that mu square equal to mu naught square against h1 such that mu square is not equal to mu naught square. So yes, you can see that here it is two-tailed distribution. Two-tailed test. So in two-tailed test, what is going to happen? W, we write reject H first. Reject H. In all the tests, we will mainly take the reference point as the null hypothesis H naught. Always take this in mind. Okay. And on the basis of this, you may like write in different wording, like reject H naught is kind of similarly like equal to the accept H. But always try to write the standard version, which is reject H naught or fail to reject H naught. Okay. But in examination, you may find accept H1, but that is only for the like make you people confuse. But reject H naught. Okay. So reject H naught if what? If W or W star. So W is greater than, obviously it's N. And again, W star greater than N. So in case of a known case, that is W star case, the degree of freedom is N minus 1. So up to this point, everything is okay. Now, since we are performing the two-tail test, again, we are performing two-tail test, and this kind of suppose distribution, chi-square distribution is of this kind, suppose. So in that case, this values alpha 1, this values alpha 2. Okay, and this is 1 minus alpha. Now, what we use is not using alpha 1 and alpha 2, instead of using alpha by 2. Okay, for the simplicity purpose. Okay, so yes, the degree of freedom will be, sorry, the level of significance will be alpha by 2 instead of alpha 1 and alpha 2. Okay, so this is the case because chi-square distribution is not symmetric in nature, but still we use alpha 1 and alpha 2 equal to alpha by 2 on both the sides for the symmetric kind of estimation or symmetric kind of testing. Okay, so
Sir,
the
excuse me, sir.
same, yes, yes.
Sir,
Yes.
if it is not symmetric, how we can distribute alpha by 2 in the right and alpha by 2 in left side?
No, it's actually the probability is like what? The reason, this reason actually, this reason should be like 1 minus alpha. Okay, so the reason, so these reason will be like something whose sum is alpha, whose sum will be alpha. Na? So that the overall the area under the curve comes out to be 1. But since it is not symmetrical in nature, so that means we can take alpha 1 and alpha 2 on both sides. Okay, alpha 1 and alpha 2. But for the simplicity purpose, we consider alpha 1 equal to alpha 2, which comes out to be alpha by 2. Okay, this is the case actually. Is it okay? I think these same has been discussed in week 8. I'm not totally sure, but we will discuss about the chi-square distribution in week 8 lecture. So there you can see. If not, then I will definitely give the derivation kind of thing as well, if you want. Okay, but this is the case. Like, see, let me write, like, draw again. See, the first one is like kind of symmetric in nature. The second one is obviously positively skewed. In normal case, what we can see, it is symmetrical in nature. Okay, so the area under this curve is 1. So that means what? That means it is actually 1 minus alpha. And it is symmetrical in nature. That means here it's alpha 1 and alpha 2 are equal. Okay, alpha 1 equal to alpha 2. So obviously comes out to be alpha by 2. Here it is clear. But in the second scenario, which is chi-square distribution, the first one is for T or normal distribution. Okay. But the second case, it is not like the symmetric distribution. It is actually positively skewed distribution. So it comes out to be like this. So it's 1 minus alpha. This area will be, so this alpha is alpha 1 and alpha 2. So we know alpha 1 plus alpha 2 comes out to be alpha. Okay. And for simplicity, we consider alpha 1 is alpha by 2. So that is the case. We use alpha 1 and alpha 2 equal to alpha by 2, alpha by 2. Is it okay? These are our assumptions so that we can see the result and like proceed further. Is there any doubt? You people have like you have any kind of doubt or anything you can share here? Is it okay? Let me know when you have any doubt. Okay, this is the case. Okay. So the next case is test for proportion. Okay, interrupt me when you find your result. The third one is like test for proportion. And for test for proportion, again, let me write here directly H naught such that P is equal to P naught against the alternative hypothesis P is not equal to P naught. Okay, a two-tail kind of thing. So in that case, what we can write, the Z statistics will be like P minus P naught whole divided by under root of P naught 1 minus P naught divided by N. Always remember the first line, let x1, x2, xn be random sample from those. That is already in all the testing. Okay, that is the starting sentence for all the testing procedure. Okay, so this is the Z statistics where we will performing the test for proportion problem. Okay, and yes, the conclusion will be drawn by reject H naught when the modulus value of Z comes out to be alpha by 2 here again. Okay, since it follows the Z distribution, so this implies its modulus value of Z is greater than Z alpha by 2 instead of alpha. Okay, this is the case. The next is like difference of mean. The test for difference of means. Okay. Now, up to this point, we will discuss about only when x1, x2, xn taken sample from one normal population. Now we have two normal population. Okay. So yes, we have like what? Let x1, x2, xn follows normal distribution with parameter mu1 and sigma 1 square. Also, y1, y2, yn follows the normal distribution again with parameter mu2 and sigma 2 square. Okay, this is the case. Now we need to perform when sigma square is known, when sigma square is unknown, kind of thing. Okay, so I'm going to write here like there are three cases now actually. Okay, there are three cases actually for this difference of means. Okay, so the first one is mu1, the first like okay, let me write the hypothesis kind of thing first. First, let me write the test statistic, and then we will write the hypothesis under three conditions. Okay. So the first condition is like sigma square. Sigma square is known. Second is sigma square is unknown. And there is one more condition because we are dealing with two different normal population. So that means sigma 1 square and sigma 2 square are unknown, but also not equal. Okay. So that means both are known, then obviously can see whether these are equal or not. But when those are not known, in that scenario, it is possible that sigma 1 square equal to sigma 2 square or it is not equal to sigma 2 square. So that is there are three possibilities. So the first one is like what? Sigma 1 square and sigma 2 square is known. In that scenario, the test statistic will be like, suppose, let me write it is Z1. So it follows something x bar minus y bar the root of, since it is known, it's sigma 1 square upon n1 plus sigma 2 square upon n2. This is the case, the simple thing. Okay. The second case is what? When sigma 1 square and sigma 2 square is unknown. When it is unknown, then obviously instead of using like s square, we use the estimate of sigma square. Okay, that is s square actually. So the Z statistics, let me write it with T1. T1 is equal to something like x bar minus y bar upon. Okay, I need to write here one more thing. Actually, I'm telling it is unknown, but it is also equal and unknown. Okay, sigma 1 square equal to sigma 2 square, and it is unknown. Okay, in that scenario, it is x bar minus y bar, and then it is like SP, kind of pooled variance. Okay, and that is multiplied by some other term, that is n1 n2 divided by n1 plus n2, its whole power 1 by 2, that is under root kind of thing. Okay, where SP square is calculated as N1 minus 1 S1 square plus N2 minus 1 S2 square whole divided by N1 plus N2 minus 2. Minus 2 is because we lack 2 degree of freedom because two parameters are unknown. Okay, so N1, sigma 1 square and sigma 2 square are unknown. So N1 plus N2 minus 2 is there. Okay, so this is the case. Now the third case is something sigma 1 square is not equal to sigma 2 square and is unknown. Okay, this is the third case. It is unknown and not equal to. So in that case, let me define the t statistics. Let me write it 2, which follows like it's x1 bar minus y1 bar upon the root of s1 square upon n1 plus s2 square upon n2. This follows obviously t distribution with the new degree of freedom. Okay, and how to calculate new? That's actually the toughest part here. The new is like s1 square upon n1 plus s2 square upon n2. It's whole square. Whole is divided by like s1 square square. That is s1 to the power 4 whole divided by n1 square. It's n1 minus 1 plus s2 squares is squares. That is s2 to the power 4 divided by n2 square n2 minus 1. This is the value. The new value is calculated via this formula. And yes, it may possible that it do not give the integral value, so to its nearest integral. Which integer is nearest to these value is our degree of freedom for the t statistic. For this, when sigma 1 square is not equal to sigma 2 square, then t2 statistic will be like that, nearest integer. Okay, so this is the case. And yes, let me write the three other cases like if h naught such that mu1 is less than or equal to mu2. Here, since we are dealing with two different populations, so mu1 is less than or equal to mu2 kind of thing, or equal to kind of thing again against h1 such that mu1 is greater than mu2. In that scenario, if reject h naught. Okay, so here we have three conditions. Always remember, here we have three conditions. The first one is under z when both are known. In that case, it's a z1 value, the z statistics z1 value. Okay, this z1 value is greater than or equal to or greater than z alpha because it's one tailed, so z alpha. Okay, then we reject the null hypothesis. Or if both are unknown and equal, then T1 statistic is there. So since unknown, so the T distribution will be like N1 plus N2 minus 2 degree of freedom. And since it is one-sided test, so it's alpha. Okay. And the third case is alpha 2. Sorry, T2. T2 is also the same. And we define the degree of freedom here by the new. So T at new degree of freedom and alpha level of significance. So this is the case when we are dealing with this type of hypothesis. The same, we will change the hypothesis. So that means H naught such that mu1 is greater than or equal to mu2 and H1 such that mu1 is less than mu2. In that scenario, we reject the null hypothesis. Reject the null hypothesis if again z1 for z1 case the same thing but minus of alpha. If t1 the same minus of t of n1 plus n2 minus 2 alpha and it's t2 it's less than or equal to minus of t nu alpha the same but okay. And the third case will be like if H0 such that mu1 equal to mu2 against H1 such that mu1 is not equal to mu2. So in that case, that means we are going to test for the two-tailed test. Okay. So for the two-tailed, the hypothesis will be by reject H0 if. So instead of using Z, we use mod Z, which is greater than Z alpha by 2, not alpha. Similarly, for T, it's greater than T n1 plus n2 minus 2 alpha by 2. And yes, for T2 again, the same thing happened. It's T nu alpha by 2. So this is the case. Okay. These are the rules we will follow for the test. There are two more things. We will discuss it in brief. Okay. So the next is paired t-test. Okay. So it's paired t-test. In paired t-test, our t-statistic is defined as like this. It's root n d star divided by sd. And what is the value of d star and sd is like, because it's paired t-test, so there's a difference di, which is actually the differences between the two variable xi and yi. Okay. And yes, then d bar is nothing but 1 by n summation di, that is the mean value. And s d square comes out to be 1 upon n minus 1 summation di minus d bar whole square. The same thing, xi minus x bar 1 minus n, same d. Okay, so this is the case. And yes, we reject the null hypothesis, we accept the null hypothesis. This also follows like the t distribution actually. This also follows the t distribution under different scenario. Okay, so we use the t distribution, so it's actually n minus 1 degree of freedom. Okay, in paired t test we use n minus 1 degree of freedom, and yes, it's alpha level of significance. The next is I'm not going to write all the three scenario. We will write when we solve the question. The last is actually the test for two variances. Test for two variances. Okay, now we will test for two variants. So this happens when means are not known. Okay, so when means are not known, in that case, we'll perform the testing for two variances. So in that scenario, our test statistic is actually F test. So which is equal to S1 square upon S2 square. And this follow the F distribution with N1 minus 1 degree of freedom and N2 minus 1 degree of freedom. Also, this formula is used when S1 square is greater than S2 square. So in F, always remember that the numerator is always greater than the denominator. Okay, this is how F test is defined. Okay, so always numerator is greater than the denominator. So if S2 is greater than our F statistic will be like S2 square divided by S1 square. Okay, so this is the case. And yes, here again, we have three conditions. Let me write here like H naught such that sigma 1 square equal to sigma less than or equal to obviously sigma 2 square against sigma 1 square is greater than sigma 2 square. Then we reject the H naught if this F value, the tabulated value F, the calculated value F is greater than or equal to the tabulated value at n minus 1 degree of freedom. Sorry, it's n1, it's n2 minus 1 degree of freedom, it's alpha. Okay, the same happened when our null hypothesis is sigma 1 square is greater than or equal to sigma 2 square versus the alternative hypothesis is like sigma 1 square is less than sigma 2 square. Again, we reject the null hypothesis if f value is less than or equal to f of n1 minus 1 into minus 1 alpha. Okay, because f distribution contains 2 degrees of freedom instead of 1. So it's n1 and n2. And the last case is like h naught sigma 1 square is equal to sigma 2 square against the alternative hypothesis sigma 1 square is not equal to sigma 2 square. That is the uh, two-tail test, obviously. For two-tail test, we reject the null hypothesis if like f value at calculated values. So I've written here f greater than or equal to f value at n1 minus 1 degree of freedom and 2 minus 1 degree of freedom at alpha by 2 level of significance, because now we are dealing with two-tail test. Okay, so this is the case. Okay, these are the testing which is covered in like week 12. Up to this point, anyone have any doubt? Please ask. Okay, or we will solve some numericals based on this, and then you may. Okay, so let me write numericals. The first numerical will be like let x1, x2, xn be a random sample. Let x1, x2, xn be a random sample from a normal population, with mean mu and variance sigma square, where sigma square is equal to sigma naught square. Okay. Now a test for H1, a test for like H naught such that mu equal to mu naught versus H1 such that mu is equal to mu1, where mu naught is greater than mu1 is. See, this is the same kind of question that we have discussed in above slide. Okay. Mu equal to mu naught. I've written here mu1. Okay, sorry. It's mu1, it's mu naught. Okay. Under h naught, mu equal to mu naught, and under h1, mu equal to mu1. Okay. But here there is a relation that mu naught is greater than mu1. So that means what? Mu is greater than or less than kind of thing. So we will solve. Always try to first write given what is given in our question. We are given like what? X1, X2, Xn follows normal with mean mu and variance sigma square. Okay. Also, we are given sigma square is equal to sigma naught square, means known, no? Not unknown. It's known. So when it is known, uh, let me first like frame the hypothesis. The next state is to find the hypothesis or frame the hypothesis. So what we are need to do, mu equal to mu naught against h1 such that mu is equal to mu1. Okay, these are given. The next step is find the statistic. Which statistics is used here? In that scenario, obviously, since sigma square is known, so obviously z statistics. So, okay, sorry. Okay, so a known case, it's known case. So obviously, we define the test statistic. Test statistic will be like z, and it is what? It is like x bar minus mu on sigma naught divided by root n, because sigma is known. In that scenario, this is the case. Now, the under the null hypothesis and actually this is the general formula. If I am written here the general formula, then under null hypothesis, under null hypothesis, this z will be converted like x bar minus mu upon sigma naught square divided by root n. Okay, so sigma naught square is given, mu under the null hypothesis, mu equal to mu naught. So this is the case. And we have calculated this because there is no numerical values given in the question. We will treat this as our calculated value. So now we H naught is rejected. If what? If this Z value is less than minus time of Z alpha, because this is the case, na? Greater than. So that means mu naught is greater and mu one is less. Mu is less than. So in that scenario, the minus will be there. So Z is less than Z alpha. And obviously it's like one-sided test or one-tailed test actually. Okay. So this is the case. And this is the question. You need to like recognize the problem, what problem it is given, like greater than, less than, and what is our decision statement. Okay, or inference. So inference will be like Z is less than minus Z alpha, then it is true. If you are written Z is greater than Z alpha, then it will be false. It will be wrong. Okay. Okay, so now let's solve the numericals on the basis of same topic. The question is like a random sample of size 10, random sample of size 10 is taken from a normal population and where the values are like 9.7, 12.67, 11.81, 7.89, 11.18, 10.83, 12.98, 12.56, 13.05, and 8.43. These are the 10 random samples are given. Okay. Now for testing the hypothesis that the mean of the population is 10, that the mean of the population is 10 against the hypothesis that it is not equal to. Against the hypothesis that it is not equal to 10. So the value of the test statistics, what we need to find is a okay, to the value of test statistics and the critical value at 5% level of significance are. Okay, so this is the question. We are given a random sample, size 10, and we are given the hypothesis, and we need to find the test statistics and the critical value at 5% under this scenario. Okay, this is the question, a straightforward question. You need to like solve this. Here it's simple. The samples are given. Okay, so first is what is given. We are given here that xi follows normal distribution with mean, mu, and variance sigma square. We are given like 10 samples, so I from 1 to 10. This is given. The next is like we are given the hypothesis. The hypothesis like we need to check mu equal to 10, the population mean equal to 10 versus it is not equal to. So that means the alternative hypothesis is mu is not equal to 10. So it implies two-tailed test. Okay. Now the next step is it given? Is it like the question mentions the variance? No, the question does not mention any variance. So that means what? Also, the sigma square is unknown. Okay. So now you know that which statistics is used here. Okay. So our statistic is actually T when sigma square is unknown and we perform the test for mean. So T, which is equal to what? X bar minus mu upon sigma square is unknown. So instead of sigma, we use S divided by root n. This is our test statistic. Now under H naught, it is mu value comes out to be 10. X bar can be calculated from this table, from this data. And yes, sigma square is also, or sorry, S square is also calculated with the help of that data. And then we will conclude whether we reject or accept the null hypothesis. Reject or fail to reject is the proper sentence. Okay. So let me first draw up X bar. What is X bar? X bar is nothing but like what? 9.7. These are numbers 9.7 plus 12.67 plus these are the numbers. Okay, I'm not going to write the whole number. Dot 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 plus it's 8.43. It's divided by total 10 sample is there. So it comes out to be like 111.10 divided by 10. So X bar comes out to be, right on the next page, 11.11. Sorry, 11.11. I mean to say 11.11 is the average value. Okay. Now we need to find the S square as well. Now S square is equal to 1 upon n minus 1 summation xi minus x bar whole square. Okay. So obviously S square is 1 upon n is 10. So n minus 1 is 9. So xi minus x bar whole square is, let me write something. It's 1.41 whole square because it's like what? It's 9.7 minus 11.11 comes out to be 1.41 whole square. In a similar manner, I can write 1.56 whole square because the next term is 12.67. It's 12.67. 12.67 minus 11.11 comes out to be 1.56 whole square. And in the same manner, I can write 0.7 whole square plus minus 3.22 whole square. I'm going to write the whole number. Okay. 0.07 whole square plus it's minus 0.28 whole square plus 1.87 whole square plus it's 1.45 whole square. I can say square instead of whole square. 1.94 square and the last is minus of 2.68 square. This is the case. Okay. Every random sample is like we take the deviation from their mean and then the square. It comes out to be this. And yes, S square comes out to be like what? 1.9881 plus 2.4336 Should I write the whole number or I should write the final, that is 7.1824? Is it okay to write this? Whole divided by n minus 1, which is 9. Okay. Now you can use your calculator, square these numbers, and then find the square terms. And then s square comes out to be like it's 31.9088. The summation will come out to be 31.9800. Sorry, 9088. And it is divided by 9 because n minus 1 is on the denominator. So s square comes out to be 3.5454. We need s. Okay? We need s. So s will be actually under root of 3.5454, which comes out to be 1.86, approximately 1.86, 1.87 kind of. Okay. So this is our answer. This is the s square. Now the next step is to find the test statistic. Now the test statistic is it's what? It's like t. T is x bar minus mu upon s by root n. Okay. So under h naught, what will be like this? X bar is 11.11 minus under h naught. Under h naught, it comes out to be 10. S comes out to be 1.86 divided by root n. Root n comes out to be under root of 10. Okay. So obviously, it is what? It looks like it's 1.11. That's whole divided by it's 1.86 divided by 3.162. Root 10 value comes out to be 3.162. And okay, there is a mistake. Actually, it's 8. Okay, so make it clear. It's 1.88. So yes, after solution, it comes out to be 1.86. The t value, the t at calculated t value comes out to be 1.86. Okay, so the test statistic is 1.86. And the critical value at 5% level of significance is like the t value, because it's actually two-tailed test. Na? So the modulus value of t is like comes out to be 1.86. Okay, at uh, at 9, at 9 level of significance, sorry, at 9 degree level of degree of freedom, at 9 degree of freedom at 5% level of significance, the t value is 1.86. Okay, so here clearly we can see that which is less than the t calculated value. So that means what? We fail to reject the null hypothesis. So that means we fail to reject the null hypothesis. So that means what? That means this hypothesis mu equal to 10, the claim that mu equal to 10 is the correct claim. Okay, on the basis of this sample, this 10 sample. Okay, so this is your interpretation. Is it okay up to this point or any doubt? Okay,
Excuse me, sir.
yes,
Sir, calculated value is 1.86
yes.
and the value at 5% of 9 degree. What is the
Okay,
value?
okay. The calculated value at, I have written here something. Okay. The tabulated value, actually the calculated value comes out to be 1.86. Okay. And the
Yes.
tabulated value is actually, okay, what is the tabulated value? At 9 level of significance comes out to be, it's 2.262. You may use the the t table. If you people have the access, then see the t table at 9 degree of freedom at 5% level of significance, you will find 2.262, the tabulated value. So here the tabulated value is this and the calculated value is this. So clearly calculated value is less as compared to the tabulated value. So in this scenario, we fail to reject the null hypothesis. Okay, is it okay?
Yes, sir. Yes.
Okay, thank you. Let's post detail actually. Okay, so this is the case, and the step is clear, and the same step is like followed for all the questions. Let me write the next question, and we will solve. The question is a random sample of size 12 random sample of size 12 is taken from a normal population with mean mu and variance sigma square. Okay. Let x bar and s square be the sample mean and the sample variance. Respectively, and t, which is equal to root n x bar minus mu naught upon s for testing h naught such that mu equal to mu naught against h1 such that mu is not equal to mu naught at 5% level of significance. The test is to okay, the same question, the same kind of question that you need to find which test statistic is used. Okay, the test statistics is given actually. You need to find the test like the conclusion. Okay, the conclusion at 5% level of significance. Okay, so obviously the smaller question. See, we have already given much thing like what? Like x1, x2, x12 follows normal with mean mu and variance sigma square. This is given here. Okay. Also, we are given the hypothesis that is mu equal to mu naught against mu is not equal to mu naught. So that means the two-tailed test. Okay. Also, since sigma square is not given here, so also sigma square is unknown. These are the three cases. Okay. And the test statistic is like, so since sigma square is unknown, so that goes to the t test. Okay. The t statistic is defined here, which is equal to x bar minus mu naught, because under the null hypothesis, it's s by root n. This is the test statistic. And this follow the t distribution with degree of freedom is n minus 1, because sigma square is unknown. So there lacks 1 degree of freedom. So instead of n, it's n minus 1 degree of freedom. And at because it is two-tailed, so it is instead of alpha, it is alpha by 2. Always remember these things, because during my graduation and post-graduation, I always get confused. Okay, when to write n, when to write n minus 1, when to write alpha, and when to write alpha by 2. Okay, that's why I'm telling all the time. Since unknown, okay, so that means there is a lack of 1 degree of freedom. So that is instead of n, the degree of freedom will be n minus 1. since the two-tailed test, here it is two-tailed, here it's two-tailed test, we are going to perform the two-tailed test. So this implies instead of using the alpha level of significance, we use alpha by 2 level of significance. Okay, so this is the case. Now what? We are given here n equal to 12. No? So n minus 1 comes out to be 11, which is our degree of freedom. Okay, and alpha is equal to 0.05 at 5% level of significance. No? So that is 0.05. So its alpha by 2 comes out to be 0.025. Okay, 2.5%. That means, so what? The t value at 11 degree of freedom and 0.025. You need to now again use the t table. You will find out it comes out to be 2.201. Okay. So since we do not have the x bar and mu and s value, mu naught and s value, so what we can generalize, like we can conclude in general sense, like what? We reject the null hypothesis H naught if the test statistic, since it is two-way, that is two-tailed, so the test statistic T is less than or greater than. Since it is the calculated value, so it is always greater
Greater.
than or it, yes, yes, it's always greater because we are focusing on the rejecting the H naught. Okay, so T is greater than T. And now the degree of freedom will be already written here 11 and 0.025. Okay. See, these are the very simple things actually. Once you write 11, 12 instead of 11 degree of freedom, it will wrong. Okay. It gives you 0 mark. If you write less than, mod of t is less than, it will award you 0 mark. Okay. So make sure you need to know the concept behind why we have written 11 or 12 or 0.025 or modulus values greater than or less than. Okay. These have already been discussed in the lecture which sir has already taught. Okay. And today also, I've written the formula only. Okay. So you may definitely get one or two questions related to these topics. And if I'm not wrong, these kind of maybe error is going to happen. There's a probable chance that these error will going to happen. Okay, so this is the case. So this is our decision. The decision will like reject the null hypothesis if the modulus value of t, that is the calculated value of the of t statistics, is greater than or equal to the tabulated value of t at 11 degree of freedom with 0.025 level of significance. Okay, so this is the case. Any doubt why I am using any this kind of thing? Then please ask. Okay, now the next question is based on the difference of mean. Okay, so let's frame the question based on differences of mean now. We will try to solve at least one question based on each topic. So, okay, it's somewhat calculative, but let me write. Two machines are utilized. The question is given two machines are utilized to fill 12-ounce net volume plastic bottle. Okay. The filling processes can be assumed to be the filling processes can be assumed to be independently normally distributed with means mu1 and mu2 and standard deviations sigma 1, which is equal to 0.018, and sigma 2, it's standard deviation, not the variance. This can also like need to pay attention. And sigma 2 is 0.021 respectively. Okay. An experiment is performed by taking random samples. Now the question is, an experiment is performed by taking random sample of size 5, by taking random samples of size 5. Okay. Random sample of size 5 from the output of each machine. Each machine, we take 5 samples from each machine. Now the question is, for testing the hypothesis, the hypothesis will be like H naught such that mu1 equal to mu2 against the alternative hypothesis H1 such that mu1 is not equal to mu2. Okay, so definitely it's two-tailed. Okay, find the value of the test statistics. Find test statistic. Okay, so this is the question. We need to find the test statistic in this scenario. So again, read the question. We are given two machines, which is utilized to fill 12-ounce net volume plastic bottles. Okay, and the filling process can be assumed to be independently normally distributed with mean value of mu1, mu2, and the standard deviation is known 0.018 and 0.021. Now, an experiment is performed by taking random sample of 5 from each output. That is, from two machines, we take 5 samples. Now, the next is we need to perform this two-tailed test. We need to find the test statistics under this scenario for these data. Yes, there is one thing that I have not missed. I am going to write, like the machine 1 has the data, na? Because we have considered the 5 data. Na? So machine 1 has data is like 12.03, it's 12.89, it's 12.43, it's 12.32, and it's 12.68. And machine B or machine 2 is 11.92, 11.99, 11.78, it's 12.07, and 12.23. Okay, so this is the case. Now, we need to find the test statistic. Okay, we are given the data. So yes, start. We are given, what we are given here is like, first what we are given. Given is like we are given xi follows, suppose xi related to machine 1 and yi is related to machine 2, I from 1 to 5 obviously. So xi follows the normal distribution with mean mu1 and variance 0.018 whole square, because that is the standard deviation. So this is, and yi again follow the normal distribution with mean mu2 and it's 0.021 square. This is given. Now what is hypothesis? Hypothesis is two-tailed hypothesis. Let me write here. Hypothesis H naught such that mu1 equal to mu2 against the alternative hypothesis H1 such that mu1 is not equal to mu2. Okay. Now we need to find the test statistic. Since sigma square or variances are known. Let me write variances instead of sigma square. Variances are known because 0.018 square and 0.021 square, these are known. Okay. So in that scenario, what we can use? We use two sample Z test. Okay. So we use two sample Z test. Up to this point, everything is like okay. Na? Since we are given these information and since variances are known, then we use Z instead of T. Okay. So up to this point, everything is okay. Now the test statistic. What will be the test statistics? It is X bar minus Y bar. And we are given two different variances. So it's under root sigma 1 is square upon n1 plus sigma 2 is square upon n2. Sigma 1 and sigma 2 are known. X bar and Y bar can be calculated from this data. Okay, so let's do this. So X bar is what? Summation of I from 1 to 5 divided by 5, which comes out to be like what? 62.35 after summation. You will perform these things. Okay. And divided by 5. So X bar comes out to be, it's 12.47. This is our X bar. Similarly, Y bar comes out to be summation I from 1 to 5. This, which is 59.99 divided by 5, which is approximately 60 and comes out to be 12. So that means Y bar comes out to be 12. Simple up to this point. Any doubt? Yes?
Sir,
Yes?
sir, why do you write Z, sir? It is T.
Because it is given, we are given here like sigma 1 square and sigma 2 square. When variance is known, then Z is used instead of T. Remember?
Sample sizes are 5 and 5, sir.
That is the case when sigma square is unknown. Okay. Since we know the variance, then I don't think I need to use the estimate instead of the population itself, population value. Okay. When you do not have the information about the population value, that is the parameter, then you have to use the statistic or the estimator. And estimator is totally based on the sample and the sample size. Okay. Estimator is based on the sample size. Then you need to focus on the sample size. But once you know the value of the sigma, that is a parameter, here the sigma 1 and sigma 2, then no need to use no need to focus on the sample size. You need to use that, but that is not the criteria to define which test statistics is used. Okay. When it is unknown, then you need to focus on the sample size. Whether it is more than 30, then it will eventually convert to the same kind of thing, that is the Z. But if sample size is 5 or 50, but sigma square is known, in that case, already use the Z test. Is it okay?
Okay, sir.
Okay. So since sigma square is known, we can directly use Z. Okay, this is the only thing. You have to like keep this in mind. If sigma square is unknown, then sample size is one of the criteria to define which test statistics is used. Although the T test is used in both the scenario, but eventually the T value converges to the Z value. Okay, this is the process. We will use the T when sigma square is unknown. But for larger value of n, the T will eventually converges to the Z value. Okay, this is the actual scenario. So now the thing is, we have calculated X bar and Y bar. We are already given the sigma 1 square and sigma 2 square. We also know that the N1 and N2, which is equal to 5. Okay, so just we need to solve this, nothing else. Okay, so what? So Z is something, it's X bar minus Y bar upon under root of sigma 1 square upon N1 plus sigma 2 square upon N2, which is what? X bar 12.47. 47 minus approximately 12. Let me write it 12. Okay. And then they divided by this value. Okay. So this value comes out to be something like this. No? 0.018 whole square divided by 5 plus 0.021 whole square divided by 5. Just use the calculator. Calculator is also allowed to use in the examination, but not the physical calculator. The calculator which is already installed, or there is always already a calculator option there in your screen. Okay, so try to use those calculator, and you will find out after calculating, you will find out it comes out to be approximately 38.1589. Okay, which is quite large value actually. But yes, this is the test statistic. Yes, and then when you are given in examination, either you are given the table or you are given the tabulated value. From there, you can compare and conclude whether the null hypothesis is going to be rejected or you are going to fail to reject the null hypothesis. Is it okay up to this point? Okay, we will solve one more question now. We will solve difference of mean related question, means related question, variance related question. Now the next question is uh, we will perform the test for variance when mean is like unknown. Okay, this is the case that we have discussed in the last topic. Yes, the question is be like the burning times of chemical flares of two different formulation are given in the following table. Assume that these follows the normal distribution. Okay. Now we are given some data. I will write later. Now the question is for test the hypothesis. For test the hypothesis that the two variances are equal. That variances are equal. The value of the test statistic. Okay, the value of the test statistic. So mainly two type of question can be framed. Probably not 100% or all the time. You need to find the test statistics and you need to see the table to find the critical value related to that test statistic and then compare and conclude. Okay, so this is the question. The data is given. I'm going to write the data as well. Okay, so there are two type of like flares na. So the type 1, let me write it T1, and type 2 is kind of T2. So T1 will be like 71, it's 84, 62, 67, 82, 85, 66, 58, 77, and 72. This is the 10 data of type 1. The type 2 is like 66, 73, 80, 58, 76, 79, 61, 61, 80, and 82. These are the 10 data of type 2 as well. Okay, we need to check the equality of variance here. Okay, so let's solve the question now. So what we are given, let me write the given statements first. We are given X follows the normal distribution with mean mu1 and variance sigma 1 square. Y follows normal distribution with mean mu2 and variance sigma 2 square. We need to frame the hypothesis like this because it is already given. We need to test the equality of variance. So that means sigma 1 square equal to sigma 2 square against sigma 1 square is not equal to sigma 2 square because it is not mentioned here. It is only mentioned here that the two variances are equal. So that means either equal or not equal. Okay. So the alternative hypothesis will be like sigma 1 square is not equal to sigma 2 square. Also, in the whole question, you haven't seen the value of mean. So that means what? Mean not known. No? So mean is not known. We need to perform the equality of two variances. So yes, the test statistic will be like what? The F test statistic is F, which is S1 square upon S2 square or S2 square upon S1 square, depending which value is greater. The greater value comes out to be in numerator and the smaller one comes out to be in denominator. And this follows the F distribution with obviously it's N1 minus 1 to minus 1 degree of freedom and where S1 square is greater than S2 square. If S1 square is less, then S2 square upon S1 square is our new test statistic. Okay. Now we need to find S1 square and S2 square. Okay. And for S1 square and S2 square, we need to calculate the X bar as well. Because since S square is equal to 1 upon N minus 1, summation xi minus x bar whole square. So first calculate x bar and y bar or x1 bar and x2 bar. Y I've used. So x bar and y bar. So let's calculate x bar, which is equal to summation xi divided by n. Okay. So summation xi, we are given 10 sample. We need to get some 71 plus 84 plus dot dot and 72, which comes out to be 724. The total sample size will be 10. So obviously it's 72.4. So x bar will be 72.4. Okay. Now y bar. Similarly, summation yi divided by n. Summation yi is comes out to be 716 divided by 10, 71.6. So y bar is 71.6. Okay. Now see, you need to use this formula for sx square or s1 square 1 upon n minus 1. So 1 by 9 summation xi minus x bar. So x bar is 72.4. So you need to create the table 71 minus 72.4, 84 minus 72.4, and then square it. So I'm just going to write the final statement. So it is like S1 square is 1 upon n minus 1 or n1 minus 1. Let me write it. Summation xi minus x bar whole square, which is 1 upon 9. Summation it's 1.96. I'm going to write this value plus 134.54 plus 108.16 plus 29.16 plus 92.16 plus 158.76 plus 40.96 plus 207.36 plus 21.16 plus 0.16. Okay, this is the case. Just minus square and then it. So S1 square is 794.4 divided by 9, which is approximately equal to 88.27. This is the S1 square. In the same way, S2 square, it's 1 by 9 multiplied by the same kind of number from here, from type 2 data, and then 71. X bar is, Y bar is 71.6. You will find, I'm going to write the summation form directly, which is 766.4 comes out to be 85.56. Okay, so S1 square is there, S2 square is there. Now the calculated value of L, that is the test statistic. F is S1 square upon S2 square, which is 88.27 divided by 85.16. So the F calculated value comes out to be approximately 1.036. This is the approximate value. Okay. You need to find this value actually. In question, you need to find the test statistics, which is this value, 1.036. Now, since we are given the degree of freedom, since N1 equal to 10, N2 equal to 10. So F value at N1 minus 1 and N2 minus 1 degree of freedom comes out to be, from the table obviously, it's 4.03 at 5% level of significance. Okay, at 5% level of significance, the F at 9 degree of freedom comes out to be 4.03. So yes, you can see here F value is less than F at 9 at 5% level of significance. So this implies what? You fail to reject the H0. You fail to reject the H0. That means what? You fail to reject this. So this means this is true under these samples. That means the two random samples which are independently are actually have the same variable. Okay. This is the case. This is the interpretation. And this is how you solve the. Is it okay up to this point? If not, please let me know. Okay.
Done.
Yes.
Yes.
Sir, alpha is 5%. That means you can take alpha by 2 here, sir.
Wait. Here in F table actually. Okay.
It's
The value
test,
of
sir.
yes. It's alpha. Actually, you need to take alpha at here. Instead of this, you need to take alpha by
0.25, sir.
99. Sorry.
0.25, huh?
Yes. This value is
99
like
degrees
kind
of
of
freedom.
0.025 comes out to be na, for total.
0.02.
Yes. Okay. And then you take you need to see the F table now. There is a N2 column and N1 degree of freedom. So N1 and N2 have an intersection N1 and N2, that is 99. You will find perhaps this value is there. Okay. Or maybe for different level of significance, you get the different tabulated value, and on the basis of those tabulated value, you may either reject the null hypothesis or fail to reject the null hypothesis. Okay. So there is one more question. Actually, there is 2 or 3 more questions. So let me solve one question at least. That is the okay. The question is like the diameter of a metal disc.
Excuse me, sir.
Yes.
Sir, if there is any polling question are there, sir? When we are
Sorry?
pulling, when we are not pulling. Sir,
Yes,
is
yes.
there any
I'm
pooling
going
question?
pooling question like when sigma 1 square is not
When
equal to
we are
sigma square
applying
type.
pooling, when we are not applying. Yeah.
Yes, I'm going to solve one question based on like we have discussed about the case now when uh, we are going to take two sample and when variances are unknown and unequal. I'm going to solve the question based on these scenario. And you want to ask the same question? You are asking the same question or some different question?
Okay. That means pooling, when we are applying pooling and when we are not applying pooling. Just
Pooling
we how to
in
recognize.
what like perhaps I'm not able to understand your question. The pooling concept you want to ask when we apply the pooling concept.
Yeah, pooling concept.
Okay, here I don't have the question related to those actually. Okay, the wait. Here we have used the. Just give me a minute. Okay. I think you are asking about this second scenario. What this kind of related problem, or you want to ask something else?
Yeah. Sir. That means
This no.
actually my question is yes sir, similar question. When we are applying pooling, when we are not applying pooling,
Okay,
is
when
there any
we apply
condition?
pooling and when. Okay. You want to know the condition behind. Okay. Okay. I think this is the condition. Maybe this P is stand for pooling. Perhaps I can remember. Okay, but if this is the correct thing, then obviously the condition will be like when we perform the testing for difference of mean and when we have unknown like like population variance, then the pooling concept is applied. It may be in this scenario, but if you want to ask in another scenario like when we perform the goodness of it kind of thing, then the pooling concept is totally based on the observed sample size. Okay, observed frequency. If you are asking from the chi-square testing concept, okay, goodness of fit test using chi-square, then there the pooling concept imply when sorry, that means we apply the pooling when the observed frequency comes out to be less than 5 in that scenario. And here it implies when we perform the differences of mean testing and then when we have sigma 1 square equal to sigma 2 square but it is unknown, then this concept is used. Or you want to ask some other thing, then please let me
Oh,
know.
okay, sir. Okay.
Okay, it may possible that I will not get your question. Okay, you may message me in that scenario, but wherever I can remember, the pooling concept is either in goodness of fit test during the chi-square testing. There, when the observed frequency comes out to be less than 5, then we pooled. Okay, that is the pooling, and that caused the la- loss of 1 degree of freedom in our model, in our testing. Obviously, goodness of fit test, but here it is maybe perhaps this only. And now I'm going to solve this scenario question. Sigma 1 square is not equal to sigma 2 square and variances are unknown. So okay, let me know. Okay, if I'm not getting your question, then let me know by mail or something, by YouTube comment or by directly contact me via LinkedIn as well. Okay, I will try to answer your question if I'm not currently answering your question. Okay, so now the question is, sorry, where the question has gone. Okay. So the question is the diameter of a metal disc as measured by two distinct calipers. two distinct calipers follow independent normal distribution with unknown mean and unknown variance. Okay, so I have written sigma and sigma square and mu. Okay, two random samples of 10 metals two random samples of 10 metal discs are taken to measure diameter with two calipers. And the corresponding outcomes are obtained as we are given two data set. Okay, then the question is like for testing the equality of means. The question is for testing the equality of means of measurement of using two calipers. The value of the test statistic and the critical value at 5% level of significance are. Here, assume variances are not equal. Okay, this is the case. Okay, so that means the case will be like sigma 1 square is not equal to sigma 2 is square, and also it is unknown. The third case that I have just shown. Okay, so we need to find the obviously the test statistics and the critical value at 5% level of significance. So I'm not like going to write the whole. Okay, sorry. Let me first give you the data. Na? So the caliper one has the data set like okay, it's 0.265, 0.265, 0.266, 0.267, again 0.267, 0.265, it's 0.267, 0.267, then 0.265 and 0.268. This is the data set. And then C2 caliper second gives the data like 0.264, 0.265, 0.264, 0.266, 0.267, 0.268, 0.264, 0.265, 265 again, and the last is 0.267. Okay, these are the data set. Okay, the measurement taken from the two calipers. Now, okay, we need to perform the testing for two means. Okay, so let's solve the question. The first thing that we need to do is what? The hypothesis is already given. Na? Hypothesis is what? For testing the equality of mean. Okay, we need to perform the test for equality of mean. I'm just going you some idea. Now going to solve the whole thing. We are given what? Xi follows the normal distribution with mean mu1 and variance sigma 1 square. Yi follow the normal distribution with mean mu2 and variance sigma 2 square. Okay. Also here we see that sigma 1 square is not equal to sigma 2 square and it's unknown. Okay, this is the case. In this scenario, you know that the test statistics that we have defined in the above slides is actually T2, where x bar minus y bar whole divided by under root of s1 square upon n1 plus s2 square upon n2. See, here sigma 1 square and sigma 2 square are not equal. This is the one case, one factor. The another one is unknown. Once the population parameter value is unknown, in that scenario, you need to use the estimate. Okay. And sigma square, the unbiased estimator of the sigma 1 square is nothing but sample variance. That is S1 square and S2 square. That is S square actually. Okay. So instead of sigma 1 square, you use sigma square, S1 square, and sigma 2 square, we use S2 square. And the sample size is N1 equal to N2 here, but I have written the general formula N1 and N2. Now, obviously, this follows, if you remember, the T distribution with new degree of freedom. Now the next is, yes, the value of nu. The value of nu is defined is like what? S1 square upon N1 plus S2 square upon N2 and its whole square, whole divided by S1 square to the square, that is S1 to the power 4 upon N1 square, N1 minus 1 plus S2 square to the square, S2 to the power 4 upon N2, N2 minus 1, it's N2 square. Okay, so this is the formula to the nearest value. Okay, the value which is nearest to this value comes out to be our degree of freedom for this T distribution. Okay, okay, up to this point. Now, from this data, okay, I'm going to write the direct value. Okay, you are advised to calculate all those values. So the values are like x bar, we need x bar, which is actually 2.662 divided by 10 because we are given 10 data sets, comes out to be 0.2662. Similarly, y bar comes out to be like 2.655 divided by 10, comes 0.2655. The x bar and y bar is there. The S1 square is also, the S1 square is actually 1.289 multiplied by 10 to the power minus 6. Okay, please calculate these values. Okay, now S2 square is like 2.055 multiplied by 10 to the power minus 6. And we are given N1 equal to 10, which is equal to N2. Okay, we are given the data, 10 data. Now this value, the denominator value, okay, x bar, y bar has been calculated. The denominator value is like what? It's S1 square upon N1 plus S2 square upon N. It comes out to be, just put the values of S1 square, S2 square, N1 and N2, and you will find out 5.78 multiplied by 10 to the power minus 4. This is the approximate value of this denominator term. Now the test statistics is already x bar minus y bar divided by this value. The next point is the new value, which is the degree of freedom. So just yes, this value has already been calculated, S1 square upon N1 plus S2 square upon N2. Now S1 to the power 4, and you need to calculate these values as well. Just the numerical and it's obviously the tedious task, but you are allowed to use your calculator. So once you are going to solve this, you will find it's 17.06. Okay. So yes, it's actually two-tailed, na? Because we need to check the equality of mean, either equal or not equal kind of case. So two-tailed. So that means alpha equal to 0.05. Then the t value at new level of significance at 0.025 comes out to be, go and see the t value, sorry, the t table at 17 degree of freedom. You will find that 2.11 kind of value, okay, from the t table. And the test statistic is like x bar minus y bar divided by this comes out to be 1.211. This is our test statistic, and this is our tabulated value, and this is our calculated value. Okay. So yes, you can see here, na, the T2 is less than the T at 17, 0.025. This implies what? We fail to reject the H0. Is it okay? Here we fail to reject H0 because obviously we find out that the calculated value is less than that of the tabulated value. Up to this point, any doubt? Anyone? Okay, then if you do not have any doubt, I think we should conclude our session here.
Excuse me,
Okay,
sir.
then. Yes.
Sir, what will be the question actually? We have to calculate the value, or we have to see whether we are accepting the hypothesis or rejecting?
See, you need to test the equality of means. Here you can see you need to test the equality of means, and the question says that value of the test statistics. You need to calculate the value of the test statistics and the critical value at 5% level of significance. So that means you are given the hypothesis, you need to calculate the test statistics, and you need to see the critical value at 5%. Once you have the test statistics and the critical value, then you may conclude. Na? So that's why I have concluded. But in question, the thing is you need to find the test statistics and you need to find the tabulated value at 5% level of significance. These are the only two questions. From these, yes.
Okay, so this type of question will be an objective.
It may possible. Yes, yes. Actually, I have the same question which is in objective form. Okay. I'm not like written the all four options because all those four options are like maybe sometimes 48, 49, or maybe this kind of thing. Na? Like the tabulated value comes out to be here 2.11. Okay. If you see at 5% level of significance, maybe you miss that it is 210. So
Yes.
you are going to see at 5%, the answer will be different. And those option is also in the option list. So you may get confused. That's why you need to know the concept behind. Okay. This two-tailed, then alpha by 2 is there. Okay. If unknown case, then the estimate of those parameter is used. Simple thing. Okay. So always write all the given information first. Like this is given. Okay. Like this is given. This is given. That's why I am already write these in bold form. Okay. These are the cases. Under these case, which test statistics is used? This test statistics. This new value is there. How to calculate the new value? This new value is calculated via this formula. And then you need to find out this as well. Sorry. In all the case, so that you are going to see the exact or correct true value or the tabulated value. And once you know these value, you can conclude. Actually, the question is only this. Now you can compare and finally conclude whether we are reject the null hypothesis or fail to reject the null hypothesis. Okay.
Sir, that means we check the mu1 equal to mu2. Am I right, sir?
Yes, yes, the same. Yes, it is actually. I have forgot to written here. It is again equality of means. That means mu1 equal to mu2. And since mu1 equal to mu2, we need to check the equality of means, and there is nothing else is given. So that means the next alternative hypothesis is mu1 is not equal to mu2. So that means two-tailed test. Simply, it may possible these kind of like wording you can see, and you may confuse if no one if some of the people don't see these kind of things, then obviously he or she may get confused, whether it's greater than or less than or not equal to. So always keep this in mind. Greater than or less than or alternative hypothesis is also one of the important things to define when the question itself does not contain the information related to these alternative hypothesis directly. Okay, it is already mentioned in the question, but not directly. Okay, anything else? Anyone?
Sir, I want to ask if you know about the patterns of questions between like divisions of questions between NAT. If you mentioned about the NAT, yes,
Okay,
you will
actually,
have
I do
NAT
not
kind
have
of.
any. Okay, actually, I do not have anything like net exam. You are asking about net exam.
No, 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 no. I'm saying numeric answer type.
Okay, okay, numeric answer. Yes, NAT. Okay. Actually, I do not have any information regarding the paper. The only thing I know is the syllabus, the lectures, and these are the numericals what I need to deliver to you. Okay. Probably the answer will be like this, na? Suppose you are get the NAT type question. The answer will be like find the test statistics, and then you need to write the correct value up to two decimal place. So the correct value is what? The correct value is 1.21. So you need to maybe write these kind of question, because the same kind of question we have like we have also attended during our gate exam. So maybe probably the similar kind of NAT question will be there. But if you people have any doubt, you may ask either on the discussion forum related to the exam, or you may directly mail. You will get your hall ticket perhaps or not. Then you will get within a
Yeah,
week.
we got the hall
Okay.
ticket
So you
for
got the hall
26th of
ticket.
April.
Then yes. So perhaps maybe there is some information from there. You can get the actual and authenticate information, because these information I do not have. But whatever I can guess is yes, you need to write the answer up to two or one decimal places and find the suppose the same question, find the test statistics. So 1.21 is the final answer. You need to type 1.21 in the computer, because your examination on computer based. Okay, there is filling the blank. There will be true, false, maybe. There will be multiple answer, maybe also possible. I'm not sure. MCQs will be there 100%, and NAT type question will also be there if possible. Okay, so you need to prepare for all the things. Is it okay?
Sir, this is the last session, sir, or you are conducting one more session?
No, no, this is the
This is
last
last.
session actually. This is the last because it is a 12-week course. No? So this is the last, and one extra session has already been conducted, no? On 3rd of April. 3rd of yes, on 3rd of April. So if you people have still doubt or want to discuss anything, you can directly or indirectly connect with me via LinkedIn, via YouTube, or via some other means as well. Okay, but this is the last. I'm officially completed my this question. Is it okay?
Do you have any
Should I
email
conclude?
address or that, sir?
Yes, yes, I have my LinkedIn address. You may directly search Chandan Gupta from IIT Patna. You will definitely find my account. But yes, this is my LinkedIn profile. Okay. So this is Chandan Gupta dash IITP. Okay. From there you can find me. Is it okay?
Okay.
Okay. And
Okay, sir.
all the lectures has already been there in the this YouTube channel. You people already have the links for all the 12 or 13 lectures. Okay. But still, you people have any doubt, please feel free to ask. Okay. So, is there anything else I can help you with?
Thank you very much.
Okay. Then, okay, let me first stop the recording. Thank you, everyone, for this nice journey. Okay.